Hello students and good afternoon. So now I am doing class for class 12. The topic is second order derivative. So today we will do more problems on second order derivative. So in the last online class also we are doing the same chapter. So this is your continuation class. Okay. So same exercise 4 section is 4 marks section, page number 321 from the same book Higher Mathematics for class 12 by S.N. Day. So this question number 15 is your homework, right? So if y is equal to tan inverse x, you have to prove that x square plus 1 into d2y by dx square plus 2x dy by dx is equal to 0. So this is your homework. Let's do question number 16 now. So if y is equal to tan inverse x whole square, you have to prove that 1 plus x square whole square d2y by dx square plus 2x into 1 plus x square into dy by dx is 2x into 1 plus x square into dy by dx minus 2 is equal to 0. So let's do question number 16 now. So here given is y is equal to, this is tan inverse x whole square. Okay. So directly you can differentiate it. So differentiating both the sides, with respect to x. So therefore dy by dx is equal to, now what is the differentiation of tan inverse x? How will you differentiate it? It is just like your x square. How will you differentiate it? It is just like your x square. So what is the differentiation of x square? 2x. So it is 2 tan inverse x. Again differentiate tan inverse x with respect to x. It is 1 upon 1 plus x square. Is that clear? Now before differentiation you can do cross multiplication here, or 1 plus x square into dy by dx is equal to 2 tan inverse x. Okay. Now again you have to differentiate both the sides with respect to x to prove this required result. So again differentiating both the sides with respect to x. Okay. So now let's differentiate this left hand side. You can use UV rule or product rule. Now keeping the first term as it is, 1 plus x square as it is, differentiate dy by dx with respect to x, which is d2y by dx square, plus, now keeping dy by dx as it is, differentiate the first term. What is the differentiation of 1 plus x square? This is only 2x, because for differentiation of 1 with respect to x is 0, and for x square it is 2x, and dy by dx is kept as it is. Dy by dx is kept as it is, which is equal to, now differentiate right hand side. So what is the differentiation of the right hand side? It is 2 into 1 upon 1 plus x square. That is, 2 is kept as it is because 2 is constant. Now differentiate tan inverse x with respect to x, which is 1 upon 1 plus x square. Now in order to prove this required result, now cross multiply. Now cross multiply by 1 plus x square. What do we get? 1 plus x square whole square into d2y by dx square plus, next cross multiply by 1 plus x square, 2x into 1 plus x square into dy by dx, which is equal to 2. Is that clear? Now take 2 to the left hand side, or 1 plus x square whole square into d2y by dx square plus 2x into 1 plus x square into dy by dx. Then plus 2 becomes minus on the left hand side. So it is minus 2, which is equal to 0. That is proved. So it is proved. So I think you have understood it. You can copy it. Now we'll do the next question now. So now we'll do the next question, that is question number 17. The question number 17 is if y is equal to e to the power m sine inverse x. This is exponential function is given. You have to prove that 1 minus x square into d2y by dx square minus x dy by dx is equal to m square y. So now let's do this problem. So here given is y is equal to e to the power m sine inverse x. Okay, so you can take log on both the sides. So after simplification you can also differentiate it, or you can differentiate it directly. So let us take log on both the sides here. So taking log on both the sides. So what do we get? Taking log on both the sides, we get log y is equal to log e to the power m sine inverse x, okay, or log y is equal to m sine inverse x becomes the coefficient into log e. So what is the value for log e? Log e means log e base e. Log e base e baneko thiyo 1. Log e, if there is no base, the base is e, and you know that log e base e is always 1. Or this is log y is equal to m sine inverse x. Okay, now you can differentiate both the sides with respect to x. Now differentiating both the sides. With respect to x. So therefore, what is differentiation of log y with respect to x? It is, you know that 1 by y into dy by dx is equal to, now differentiate this right hand side. M is constant into 1 upon root over 1 minus x square. Is that clear? Now you can do cross multiplication. Before differentiation you do cross multiplication. So what do we get? Or root over 1 minus x square into dy by dx is equal to, it is root under 1 minus x square into dy by dx is equal to my, which is equal to my, right? Now in order to differentiate it, let us square both the sides so that square will be removed and it will be easier for you to differentiate. Okay, so write down squaring both the sides. So squaring both the sides, what do we get? So here square root will be removed. That is root under 1 minus x square whole square is 1 minus x square into, this is your dy by dx whole square, which is equal to m square y square. Okay, now you can easily differentiate both the sides with respect to x. So again differentiating both the sides, with respect to x. So therefore, so on the left hand side you can use UV rule. You know UV rule, isn't it? Or product rule. Now keeping the first term as it is, 1 minus x square. So differentiate dy by dx whole square. So first of all it is in the form x square. What is the differentiation of x square? 2x. So 2 into dy by dx into, again differentiate the term which is assumed as x. That means you have to differentiate dy by dx with respect to x. So that is your d2y by dx square. Is that clear? Now next, keeping dy by dx whole square as it is, differentiate 1 minus x square. So what is the differentiation of 1 minus x square? It is minus 2x into dy by dx whole square. It is kept as it is. So which is equal to m square into, now differentiate y square with respect to x. This will be 2y into dy by dx. So this is your 2y into dy by dx. Now you can take common here. So dy by dx whole square means dy by dx into dy by dx. So on the left hand side, what is common there? 2 into dy by dx is common. 2 into dy by dx is taken common within second bracket. 1 minus x square into d2y by dx square minus here again 2 is taken common out here. One of these dy by dx is taken out here, that is it is taken common. So what is the remaining term here? It is x into dy by dx. It is x into dy by dx. Second bracket is closed, which is equal to m square into 2y into dy by dx. So here you can cancel. 2 gets cancels and dy by dx also gets cancels, as dy by dx not equal to 0, right? So here since dy by dx not equal to 0 in this case, so that is this dy by dx can be cancelled. So what are the remaining terms now? Therefore 1 minus x square into d2y by dx square, then minus x dy by dx minus x dy by dx, which is equal to m square y, which is equal to m square y. So we have proved it. Okay, so proved. So we can copy it. Now we'll do the next question now. So now we'll do the next question, that is question number 18. So this 18 and 19 are of similar types. So number 19 will be a homework. We will do number 18 here. Okay. So question number 19 is, if y is equal to sine within bracket 2 sine inverse x, prove that 1 minus x square into d2y by dx square is equal to x dy by dx minus 4y. So this is your homework. Now we'll do similar type of question, that is question number 18. So here given is, if y is equal to cos of within bracket m sine inverse x, here m is constant, prove that 1 minus x square into y2 minus x y1 plus m square y is equal to 0. Now you know that y1 is dy by dx and y2 is d2y by dx square. Okay, so here given is y is equal to cos of within bracket m sine inverse x. Now differentiate both the sides with respect to x. Now differentiating both the sides with respect to x, so it is dy by dx. So it is just like your cos x. What is the differentiation of cos x? Minus sine within bracket x, here is m sine inverse x. Again you have to differentiate the term which is assumed as x. That means you have to differentiate m sine inverse x with respect to x. That is, it will be m upon root over 1 minus x square. Is that clear? Is that clear now? So now you can do cross multiplication here. You can do cross multiply, or root over 1 minus x square into dy by dx, which is equal to minus m is taken outside, that is before sine you write m, minus m sine of within bracket m sine inverse x. Is that clear? Now let us remove this square root. Okay, so squaring both the sides, squaring both the sides, squaring both the sides. So what do we get? This square root will be removed, that is you will get 1 minus x square into dy by dx whole square. This is dy by dx whole square, which is equal to, on the right hand side also you have to square it. So minus whole square, as you know that it is plus sign, so it is m square. What is sine of m sine inverse whole square? It is sine square within bracket m sine inverse x. So I think you have understood it. Okay, now let us simplify it again before differentiation, because if you have cos of m sine inverse x, you can write y, so you can convert this sine square m sine inverse x in terms of cos, As you know that sin square x is equal to 1 minus cos square x. You know this formula, isn't it? So similarly, you can convert this sin square m sin inverse x into 1 minus cos square m sin inverse x. Is that clear now? So let us write it here. 1 minus x square into dy by dx whole square is equal to m square within second bracket 1 minus cos square theta, but here it is cos square m sin inverse x. So I think you have understood it. Okay, now instead of cos m sin inverse x, what can you write? Y. So it will be y square. Okay, so or this is your 1 minus x square into dy by dx whole square is equal to m square into within bracket, what do we have? 1 minus y square. Is that clear? Now it is the simplified form. Now you can differentiate both the sides with respect to x. Now let us write differentiating both the sides with respect to x. Okay, now you can use UV rule on the left hand side, right? So keeping 1 minus x square as it is, differentiate dy by dx whole square, 2 into dy by dx into again differentiate dy by dx with respect to x, that is your d2y by dx square. Is that clear? Now next, plus, now keeping dy by dx whole square as it is, differentiate the first term, that is 1 minus x square. So what is this differentiation? It is minus 2x. For 1 it is 0, minus for x square it is 2x. So what is 0 minus 2x? Minus 2x. Now keeping dy by dx whole square as it is, right? So which is equal to, now m square is constant, keep it as it is, into, now what is the differentiation of 1 with respect to x? It is 0. For minus y square, what is the differentiation? What is this differentiation with respect to x? Minus 2y into dy by dx. Minus 2y into dy by dx. Minus 2y into dy by dx. Is that clear? Or what is common on the left hand side? It is 2 dy by dx. This dy by dx whole square means dy by dx into dy by dx, or you can write 2 into dy by dx. Now within second bracket, what do we write? 1 minus x square into d2y by dx square. Then plus and minus is minus, 2 is taken common out here. One of these dy by dx is also taken common out here. So here it remains x into dy by dx. Second bracket closed, which is equal to m square into minus 2y into, this is your dy by dx. So I think you have understood it. Okay, so from both the sides you can cancel, 2 gets cancels, also dy by dx gets cancels, as dy by dx not equal to 0. So what do we get now? Or 1 minus x square into d2y by dx square minus x into dy by dx, which is equal to minus, this is your m square y. So I think you have understood it. Okay, now next you can replace, yeah, question mark jasto cha त्यसै लेख्ने. Now you can replace d2y by dx square by y2 and dy by dx by y1. So what do we get? Therefore 1 minus x square into, what is d2y by dx square? y2, right? Minus x y1, which is equal to, you can take minus m square y to the left hand side. So it becomes plus m square y is equal to 0. So we have got the answer, right? So it is done, proved. So it is very, very important problem. Okay, so both this 18 and 19 are very, very important. So your 19, this question number 19 is your homework. Okay, so in this case you can use another method also. Here we have directly differentiated, isn't it? Y is equal to cos m sin inverse x. We have differentiated directly. Or you can simplify this given in order to remove this cos and sin inverse in order to prove this given relation. Okay, so now we will use another method. So copy it first. Now we will do another method for this question number 18, right? So your number 19 garda jun chai method use garda huncha. You can use any method for question number 19. Okay, so let's do question number 18 again. So now here given is, we'll do another method now. Here given is y is equal to cos of within bracket m sin inverse x. So in the first method we have differentiated it directly. Okay, now in this case we will do another method. Let us take this cos to the left hand side. यो cos लाई हामीले लेफ्ट साइडमा ल्याउँदा के भएर आउँछ, cos इन्भर्स भएर आउँछ. Therefore cos inverse y is equal to m sin inverse x. Is that clear to all of you? Cos लाई हामीले लेफ्ट साइडमा ल्यायौं, so it becomes cos inverse y is equal to m sin inverse x. Now you can differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So what is the differentiation of cos inverse y with respect to x? So first of all, it is in the form cos inverse x. What is the differentiation of cos inverse x? Minus 1 upon root over 1 minus here x is y square into it is dy by dx is equal to m into. Now differentiate sin inverse x with respect to x. What is it? It is 1 upon root over 1 minus x square. So I think you have understood it. Now again you have to differentiate it. Before that you do cross multiplication. Okay, so or this is your root over 1 minus x square into dy by dx. This is your minus sign, right? So which is equal to on the right hand side it will be m into root over 1 minus y square. Is that clear? So now remove square root. What will you do? In order to remove square root, you have to square both the sides. So squaring both the sides. Squaring both the sides. Right? So squaring both the sides. What do we get? So square root will be removed. And this minus whole square becomes plus. So it is 1 minus x square into dy by dx whole square. Dy by dx whole square is equal to m square into m square, m whole square, m square, and here also on the right hand side the square root will be removed and you will get 1 minus y square. Is that clear now? Now you can differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So what do we get? 1 minus x square is kept as it is. You know the differentiation of dy by dx whole square. It is 2 into dy by dx into d2y by dx square. You know the rule here. And again dy by dx whole square is kept as it is. Now differentiate 1 minus x square. So it will be 0 minus 2x. So it is minus 2x into dy by dx whole square, right? So which is equal to m square into, now differentiate 1, it is 0. For minus y square, what is the differentiation of minus y square with respect to x? It is minus 2y into dy by dx. Is that clear now? So on the left hand side, what is common out here? You can take common here. Common is 2 into dy by dx is taken common. So within second bracket 1 minus x square into d2y by dx square minus 2 and one of these dy by dx are taken common, so we have x into dy by dx. Second bracket is closed, which is equal to m square into minus 2y into dy by dx. So I think you have understood it. So here you can cancel 2 dy by dx, and here also 2 dy by dx gets cancels, as dy by dx not equal to 0, since dy by dx are not equal to 0. That's why you can cancel dy by dx from both the sides. So now what are the remaining terms? 1 minus x square into d2y by dx square, right? Next, minus x dy by dx, which is equal to, on the right hand side, it is, there is minus sign, so it is minus m square y, and there 2 into dy by dx is cancelled. So now you can replace d2y by dx square by 1 minus x square d2y by dx square by y2. You can replace d2y by dx square by y2 minus x y1, then minus, it becomes plus on the left hand side, so it is plus m square y is equal to 0. So it is proved. So I think you have understood it, so you can copy it. So this is very, very important question, so you can use any of these two methods for question number 19. Okay, now we'll do the next question. So now we'll do the next question, that is question number 20. If y is equal to 3 e to the power 2x plus 2 e to the power 3x, you have to prove that y2 minus 5y1 plus 6y is equal to 0. So in this case we'll do different methods. First of all, so y1, you know that it is dy by dx, and y2 is d2y by dx square. So first of all, let us get the value for dy by dx and d2y by dx square and put them on the left hand side, including y, to prove this LHS is equal to 0. Okay, so here given is y is equal to 3 e to the power 2x plus 2 e to the power 3x, right? So differentiating both the sides with respect to x. So therefore it is dy by dx is equal to 3 into, now differentiate e to the power 2x with respect to x, e to the power 2x into 2 plus 2 is kept as it is. Now differentiate e to the power 3x, e to the power 3x into 3. So or this is dy by dx is equal to 3 2s as 6 e to the power 2x plus again 2 3s as 6 e to the power 3x, right? So now again you have to differentiate both the sides with respect to x. So again differentiating both the sides with respect to x. Again you differentiate both the sides with respect to x. So therefore this will be d2y by dx square is equal to, now 6 is constant, it is kept as it is, differentiate e to the power 2x, e to the power 2x into 2 plus 6, differentiate e to the power 3x, e to the power 3x into what? It is 3. Okay, so therefore this is your d2y by dx square, which is equal to, now on the right hand side, 6 2s are 12 e to the power 2x, right? It is 6 2s are 12 e to the power 2x plus 6 3s are 18 e to the power 3x plus 6 3s are 18, this is e to the power 3x. Is that clear now? So now let us put these values of y2, that is d2y by dx square, y1, that is dy by dx, including y on the left hand side. Okay, so now this LHS now becomes y2 minus 5y1, okay, plus 6y. So let us put these values. What is y2 now? y2 here is, that is the value for d2y by dx square. So which is 12 e to the power 2x plus 18 e to the power 3x minus 5 into, what is y1 here? Y1 is the value for dy by dx, that is 6 e to the power 2x, 6 e to the power 2x plus 6 e to the power 3x plus 6 e to the power 3x. Okay, now next, plus 6 into, what is the value for y? You have to put the value for y, which is given here, 3 e to the power 2x, 3 e to the power 2x plus 2 e to the power 3x, 2 e to the power 3x. So I think you have understood it. So let us simplify it to prove this left hand side is equal to 0. So which is equal to 12 e to the power 2x plus 18 e to the power 3x. Okay, now multiply by minus 5 here. Minus 6 5s are 30 e to the power 2x minus 6 5s are 30 e to the power 3x. Plus next, now multiply by 6 here. 6 3s are 18 e to the power 2x plus 6 2s are 12 e to the power 3x. Okay, now let us simplify it again. So which is equal to, now this 12 e to the power 2x plus 18 e to the power 2x. What is 12 e to the power 2x plus 18 e to the power 2x? It is 30 e to the power 2x, right? And next, this minus 18, plus 18 e to the power 3x plus 12 e to the power 3x. How much is it? Same sign, you can add them. Plus 18 plus 12 is 30 e to the power 3x. 30 e to the power 3x, right? Then you can write down these two terms, minus 30 e to the power 2x, minus 30 e to the power 2x, minus 30 e to the power 3x. Is that clear to all of you? So we have simplified it. Now we can cancel this plus minus sign. 30 e to the power 2x minus 30 e to the power 2x can be cancelled, and then 30 e to the power 3x minus 30 e to the power 3x can be cancelled, which is equal to 0. So which is equal to your right hand side. Okay, so we have proved it. Okay, so you can copy it. Now we'll do the next question now. So now we'll do the next question, that is question number 21. The question is, if y is equal to log x whole divided by x, you have to prove that the value for d square y by dx square at x is equal to 1 is equal to minus 3. So this expression means you have to get the value for d2y by dx square at x is equal to 1, which is equal to minus 3. You have to prove it. Okay, so here given is y is equal to log x upon x. Now let us differentiate both the sides with respect to x. So differentiating both the sides, with respect to x. So therefore dy by dx is equal to, use u by v rule. In this case you can use u by v rule. Okay, keep the numerator as it, keep the denominator as it is. Now you have to keep the denominator as it is. Take the differentiation of the numerator, that is, what is the differentiation of the numerator? Log x, that is 1 by x, minus, now numerator is kept as it is, into, take the differentiation of the denominator, that is, what is the differentiation of x with respect to x? That is 1, this whole divided by x square. Is that clear? So here you can cancel this, x gets cancels, or this is your dy by dx is equal to 1 minus log x this whole divided by x square. Is that clear? Now again you have to differentiate it to get the value for d2y by dx square. So again differentiating both the sides with respect to x. Okay, so now this dy by dx becomes d2y by dx square is equal to, now again differentiate the right hand side. So again here also you have to use u by v rule, because both numerator and the denominator are the variables. So use the u by v rule or quotient rule for the differentiation. Okay, now keeping the denominator as it is, take the differentiation of the numerator. So 1 minus log x, what is this differentiation? Minus 1 upon x, then comes minus sign. So numerator is kept as it is, that is 1 minus log x is kept as it is. Now take the differentiation of the denominator, that is your differentiation of x square is 2x, you know that. Differentiation of x square is 2x. Okay, so whole divided by denominator whole square. What is denominator whole square? This is your x square whole square. Okay, now here you can cancel this, x and square gets cancels, or this is your d2y by dx square, which is equal to, now let's simplify the numerator. This is minus x minus 2x minus or minus plus 2x log x whole divided by, this is your x to the power 4, right? So now let us simplify it, or d2y by dx square is equal to minus 3x plus 2x log x, this whole divided by x to the power 4. Is that clear to all of you? Now you have to get the value for d2y by dx square when x is equal to 1. So, or write it within third bracket, d2y by dx square, third bracket is closed. So here you can put x is equal to 1, which is equal to minus 3 into 1 plus 2 into 1 log 1, this whole divided by 1 whole to the power 4. Okay, let's simplify it, which is equal to minus 3 plus 2 ones are 2, log 1 means 0. You know that log 1 is 0, whole divided by what is 1 whole to the power 4, that is 1. So which is equal to minus 3. We have got the result. So it is proved. Understood? So you can copy it. Now we'll do the next question now. So now we'll do the next question, that is 22 number 1. If x square plus y square is equal to a square, so that 1 plus y1 square whole to the power 3 by 2 divided by y2 is equal to minus a. So in this case also you have to find out y2 as well as y1. So what is y1? dy by dx. What is y2? d2y by dx square. So let us find out these two terms, that is y1 as well as y2. So here given is x square plus y square is equal to a square. Now differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So therefore, what is the differentiation of x square with respect to x? 2x plus differentiate y square with respect to x, 2y into dy by dx, which is equal to 0, right? So, or now this is 2y into dy by dx is equal to minus 2x. Is that clear? So here you can cancel this, 2 gets cancels, or what is dy by dx now? So dy by dx is equal to minus x upon y. So this is the value for dy by dx. So this is y1 also. Now again you have to find out y2. So how can you get y2? Again you have to differentiate both the sides with respect to x. Again differentiating both the sides with respect to x. Okay, so let us differentiate both the sides with respect to x again. So therefore it is d2y by dx square is equal to, now you can use u by v rule here since minus sign is there. So write down minus sign and within third bracket use u by v rule. So keeping the denominator as it is, take the differentiation of the numerator. So that is y into 1 minus x is kept as it is now. That is numerator is kept as it is. Take the differentiation of the denominator with respect to x. That is differentiate y with respect to x. That is dy by dx. So this whole divided by denominator whole square. What is denominator whole square? This is your y square. So is that clear to all of you? So I think you have understood it. So you have to put the value for dy by dx there. What is dy by dx? It is minus x by y. So or d2y by dx square is equal to minus y1s are y minus x into, what is the value for dy by dx? dy by dx is minus x by y minus x by y, this whole divided by y square. Then here third bracket is closed, right? So or this is your d2y by dx square, which is equal to minus, so what's the LCM here now? It is y is the LCM. So y into y is y square, minus into minus plus, x into x is x square. So whole divided by, this is your y square. So I think you have understood it. So now, so what will you do in the next step? So you can put the value for x square plus y square from given, isn't it? What is x square plus y square from given? It is a square. And this y and y square both are in the denominator. Okay? So now, in this case, d2y by dx square is equal to minus, so y square plus x square, you know that from given it is a square, divided by y into, this is your y square upon 1. So when it goes up in the numerator, it becomes upside down. So you can write into 1 upon y square. So it is d2y by dx square is equal to minus a square by y cube. That is d2y by dx square is equal to minus a square by y cube. Now let us prove this LHS is equal to RHS. So what is left hand side now? LHS is equal to 1 plus y1 square whole to the power 3 by 2 divided by y2. Okay? So now let us prove this left hand side is equal to minus a, which is equal to 1 plus, actually what was y1? y1 was minus x by y whole square. Second bracket close, again whole to the power 3 by 2 is there. Whole divided by, what is y2? The value for y2 is here. That is d2y by dx square is equal to minus a square by y cube. This is minus a square divided by y cube. Is that clear to all of you? Now let us simplify it again. So now let us simplify it in order to prove right hand side which is equal to minus a. Okay, so let us prove it now. So which is equal to, within second bracket, 1 plus minus whole square is plus, that is your x square by y square, second bracket closed, whole to the power 3 by 2 divided by minus, this is your a square by y cube. Is that clear? So which is equal to, what's the LCM here now? This is your y square. So this is y square plus x square whole to the power 3 by 2 divided by minus a square by y cube. Is that understood now? Now again you can simplify it further. So instead of this x square plus y square, what can you write? A square, isn't it? This is x square plus y square, which is equal to a square. So you can put the value here, a square by y square whole to the power 3 by 2 divided by minus a square by y cube. Is that clear? So which is equal to, now this whole to the power 3 by 2 is for both a square as well as y square. So what is a square whole to the power 3 by 2? 2 gets cancelled, you get a cube. This is your a cube divided by y square whole to the power 3 by 2, 2 gets cancels, y cube divided by, in the denominator, minus a square upon y cube. Is that clear to all of you? So here y cube gets cancels, and here a square and cube gets cancels, which is equal to, now this is minus sign, you can take it in the numerator and write minus sign. So this is only a square a cube like what the times answer, a times, that is your minus a, which is equal to right hand side. So it is proved. Is that clear to all of you? So this is the answer. So now we'll do the next question now. So now we'll do the next question, that is 22, number 2. If y is equal to x cube and k is equal to d2y by dx square divided by 1 plus dy by dx whole square whole to the power 3 by 2, then find the value of k at within bracket 1 comma 1. Here the value for y is given in terms of x, that is y is equal to x cube, and also the value for k is given, it is d2y by dx square divided by within third bracket 1 plus dy by dx whole square whole to the power 3 by 2. Then you have to find out the value of k at within bracket 1 comma 1. That means this within bracket 1 comma 1 means when x is equal to 1, y is equal to 1. Here we can put x is equal to 1, y is equal to 1. Okay. Now from the first given, let us get the value for dy by dx as well as d2y by dx square. Okay. So here given here is y is equal to x cube. Now you write down differentiating both the sides with respect to x. Therefore dy by dx is equal to, this is your 3x square. Is that clear? Again differentiate it to get d2y by dx square. So again differentiating both the sides, with respect to x. So what do we get? d2y by dx square is equal to, how much is it? 3 into x square को differentiation 2x, that is your 6x. So we have got the value for d2y by dx square. Is that clear? So next, now let us put these values of dy by dx and d2y by dx square in the second given equation. So again here given is k is equal to d2y by dx square divided by within third bracket 1 plus dy by dx whole square third bracket closed whole to the power 3 by 2. So that is given. Okay. So let us put the value for both first order and second order derivative. So therefore k is equal to, what is d2y by dx square? It is 6x. This is your 6x divided by within third bracket 1 plus, what is dy by dx? It is 3x square. So it is 3x square whole square, 3x square whole square, right? Dy by dx is 3x square, so it is whole square third bracket closed whole to the power 3 by 2. I think you have understood it. So or k is equal to, this is your 6x divided by 1 plus, what is 3x square whole square? This is 9x to the power 4. So this is whole to the power 3 by 2. So I think you have understood it. So now you can put the values here. That is, you have to find out the value for k at the point within bracket 1 comma 1. So what does it mean? X is equal to 1, y is equal to 1. But since there is no y out here, you just put the value for x, which is equal to 1. So putting x is equal to 1. Okay. So therefore k is equal to, this is 6 into 1 whole divided by 1 plus 9 into 1 to the power 4 whole to the power 3 by 2. So I think you have understood it. So let us simplify it now. Or k is equal to, this is 6 ones are 6 divided by, in the denominator it is 1 plus 1 to the power 4 is 1, 9 into 1 is 9, and it is whole to the power 3 by 2. So I think you have understood it. Or let us simplify it. K is equal to 6 divided by 9 plus 1 is 10 whole to the power 3 by 2. So how can you simplify 10 whole to the power 3 by 2? So you can write it as 10 cube whole to the power half, isn't it? Or k is equal to 6 divided by 10 to the power 10 whole to the power 3 by 2 is there. It can be written as 10 cube whole to the power half, right? So if you multiply these two powers, you will get 3 by 2. So it can be written as 10 cube whole to the power half. And so you know that whole to the power half means square root, right? The whole to the power half भनेको चाहिँ के हो? Square root. Or k is equal to 6 divided by whole to the power half means square root of 10 cube. So what is square root of 10 cube? You know that square root of 10 cube is 10 root 10, isn't it? So, or this is k divided by k is equal to 6 divided by, it can be written as 10 square into 10. Or k is equal to 6 divided by, what is square root of 10 square? That is your 10. And this is root 10, right? So 6 and 10 are there. So you can cancel it by 2. 2 3s are 6. 2 5s are 10. That means k is equal to 3 divided by 5 root over 10. So this is the final answer. So I think you have understood it. So now we'll do the next question now. Now we'll do the next question, that is 22 number 3. It is given that if x is equal to a cos cube theta and y is equal to a sin cube theta. So in this case the two variables x and y are expressed in terms of a third variable theta. Here theta is a parameter and this equation is known as the parametric equation. You have to show that 1 plus y1 square whole to the power 3 by 2 divided by y2 is equal to 3a sin theta cos theta. You prove LHS is equal to RHS. Okay. So first of all, let us find out dy by dx of this parametric equation. Okay. So here given is x is equal to a cos cube theta. Now write down differentiating both the sides with respect to theta. Therefore dx by d theta is equal to a into, how will you differentiate it? Let us take it as x cube. What is the differentiation of x cube? 3x square. So this will be 3 cos square theta into, again you have to differentiate the term which is assumed as x with respect to theta. So in this case cos theta was taken as x. Let us differentiate this cos theta with respect to theta. So what is this differentiation? Minus sin theta. Is that clear? So or this is dx by d theta is equal to minus 3a cos square theta into sin theta. So let us mark it as number 1, right? So again y is equal to a sine cube theta. Now let us differentiate both the sides with respect to theta. So differentiating both the sides with respect to theta. So therefore dy by d theta is equal to a into, now differentiate sine cube theta with respect to theta. What is it? 3 sine square theta into, again differentiate sine theta with respect to theta, which is cos theta. So or now this is dy by d theta is equal to 3a sine square theta into cos theta, and let us mark it number 2. Now for y1 you have to get the value for dy by dx. That means you have to divide 2 by 1. So dividing 2 by 1. So dividing 2 by 1. Lo अब हामी 2 लाई 1 ले divide गर्छौं. So in the numerator you write down left hand side of number 2. In the numerator you write down left hand side of number 2, that is dy by d theta divided by, now you have to write down left hand side of number 1 in the denominator, that is your dx by d theta, which is equal to, on the right hand side you write down right hand side of number 2 in the numerator, that is 3a sine square theta cos theta, 3a sine square theta cos theta divided by, and in the denominator you have to write down right hand side of number 1, that is minus 3a cos square theta into sine theta. So I think you have understood it. So here you can cancel 3a gets cancels, cos theta and square gets cancels, and here also sine theta and square gets cancels. So what do we get here? That is dy by dx, which is equal to, now it is minus, this is your only sine theta by cos theta is there, so which is equal to minus tan theta. So minus, this is your sine theta by cos theta, which is equal to minus tan theta. So this is your dy by dx. Now what will you do? Again you have to differentiate it with respect to x. So differentiating both the sides with respect to x, that is we are differentiating both the sides with respect to x. So now this will be d2y by dx squared, which is equal to, now on the right hand side, now this is in the form tan theta, you should take it as tan x. What is the differentiation of tan x? It is sec square x, but here it will be sec square theta. So which function was taken as x? Theta was taken as x, and you have to differentiate this theta again with respect to x. So it is d theta by dx. So don't forget to differentiate this theta with respect to x. So I think you have understood it. Now you have to put the value for d theta by dx again. So or this is your d2y by dx square is equal to minus sec square theta into. So what was the value for d theta by dx? In number 1 we have got the value for dx by d theta, which is equal to minus 3a cos square theta sin theta. But you have to get the value for d theta by dx. D theta by dx, that means you have to invert both the sides. So what do we get? 1 upon, this is minus 3a cos square theta sin theta. So I think you have understood it. So what is the value for d2y by dx square now? So or d2y by dx square is equal to, how much is it now? So minus into minus is plus, 1 upon 3a, right? 1 by cos square theta is sec square theta, sec square into sec square, it is sec to the power 4 theta into, what is 1 by sin theta? There is 1 by sin theta is there. What is 1 by sin theta? It is cosec theta. So is that clear now? So we have got the value for d2y by dx square or y2. Now let us prove this LHS is equal to RHS. Now write down LHS. So what is LHS here? It is 1 plus y1 square whole to the power 3 by 2 divided by this is your y2. Now let us put the value for y1 as well as y2. So which is equal to 1 plus, what is y1 here now? What is y1? It is minus tan theta. It is minus tan theta whole square, second bracket close, whole to the power 3 by 2 whole divided by, what is y2? So y2 here is 1 upon 3a sec to the power 4 theta into cosec theta. So I think you have understood it. Now let us simplify it further. So which is equal to within bracket 1 plus, what is minus whole square plus, that is your tan square theta whole to the power 3 by 2 divided by 1 by 3a sec to the power 4 theta into cosec theta. So I think you have understood it. So let us simplify it further now. Let us simplify it further now. So which is equal to, what is 1 plus tan square theta? You know that it is sec square theta. It is sec square theta whole to the power 3 by 2 divided by, in the denominator, 1 by 3a into sec to the power 4 theta into cosec theta. Is that clear? So after simplification, 3a goes up in the numerator. Now what is sec square theta whole to the power 3 by 2? It is sec cube theta. This is your sec cube theta divided by, this is your sec to the power 4 theta into cosec theta. Is that clear? So now here we can cancel sec cube theta and this 4 will be cancelled. That is, one of the sec theta remains in the denominator. So which is equal to 3a. What is 1 by cosec theta? It is sin theta, right? What is 1 by sec theta? It is cosec theta. So it is proved. Understood? So you can copy it. So now we'll do the next question now. So now we'll do the next question, that is question number 23. If PV to the power gamma, this is known as gamma, Greek letter, which is equal to C, so that V square into d2P by dV square is equal to gamma into gamma plus 1 into P. So you have to prove this result. Okay, so this question is from HS 2016. So your question say 2016 ma pani aako cha. Bujhyo? So what is given here? PV to the power gamma is equal to C. You have to prove that V square d2P by dV square is equal to gamma into gamma plus 1 into P. So in this case, you should know which are the variables and which are constants. So in order to prove this d2P by dV square, you have to find out first dP by dV. You know that, isn't it? dP by dV. You have to find out dP divided by dV. That means P and V are the variables here. P and V is a variable or a constant. That means this gamma and C will be constant. Only P and V are the two variables in this case, and gamma and C are constants. Is that clear? So let us do the solution now. So here given is PV to the power gamma is equal to C. So you can use logarithm on both the sides to differentiate it. So it will be easier for you to differentiate if you take log on both the sides. So therefore this is log PV to the power gamma is equal to log C, right? Or this is your log P plus log V to the power gamma is equal to log C, or this is your log P plus, because of this log, this gamma power becomes a coefficient because this is from the properties of logarithm. So it is gamma log V is equal to log C. Is that clear now? So now you can differentiate it to get dP by dV. That is, differentiating both the sides with respect to v, because we have to get dp upon dv. In the denominator there should be dv, so differentiate both the sides with respect to v, differentiating both the sides with respect to v. So what is the differentiation of log p now? 1 upon p into dp by dv plus gamma is constant, remains as it is. What is the differentiation of log v? 1 upon v is equal to, for log c it is constant, so its differentiation is 0. Is that clear? So now let us find out the value for dp by dv first, or 1 upon p into dp by dv is equal to minus gamma by v. Is that clear? So now what is the value for dp by dv? So it is dp by dv is equal to minus gamma into p by v. Is that clear? So p is taken to the right hand side, so you can cross multiply. So you will get dp by dv is equal to minus gamma is constant dot p upon v. That is minus gamma into p upon v. Now again you have to differentiate it to prove the required result. Okay. So again differentiating both the sides with respect to x. So this is your d square p by dv square is equal to minus gamma is kept as it is because it is constant, and for p by v, for its differentiation you should use u by v rule or quotient rule. Now denominator v is kept as it is, v into what is the differentiation of p with respect to v? Oh sorry, again differentiating both the sides with respect to v. Sorry, this one is v, right? So again differentiating both the sides with respect to v, not x. That is wrong. So you have to differentiate both the sides with respect to v. Okay. So here this minus gamma is constant. Okay. So d2p by dv square is equal to minus gamma is constant. It is kept as it is. And for p by v, you have to use u by v rule. You know the quotient or u by v rule for differentiation, isn't it? Now denominator is kept as it is. V into differentiate p with respect to v, dp by dv, right? Is that clear? V into dp by dv, v into dp by dv. Then next minus. Now p is kept as it is into, now differentiate v with respect to v. What is it? It is always 1 whole divided by v square. So I think you have understood it. Okay. Now in order to prove this relation, you have to prove this relation, that is v square d2p by dv square is equal to gamma into gamma plus 1 into p. So now let us do cross multiplication. So it is v square into d2p by dv square. This is d2p by dv square is equal to minus gamma within third bracket v into, what is dp by dv? So dp by dv here is minus gamma p divided by v. Then minus p into 1 is always p. So I think you have understood it. So we have put the value for dp by dv, which is equal to minus gamma p by v, bracket closed, then minus p. Here third bracket is closed. So v square is taken to the left hand side. It is cross multiplied. Okay. So here vv gets cancels. So or v square into d2p by dv square, which is equal to, now multiply them. So it is minus into minus is plus gamma square p. So again minus into minus plus gamma into p, gamma into p. Okay. So what is common out here? Or v square into d2p by dv square is equal to, what is common here? Gamma p. So within bracket what do we have? What do we have within bracket? Gamma p is taken common. So within bracket we have gamma plus 1. So which is proved. Is that understood? Or you can write it as b square d2p by dv square is equal to, now you first write gamma, then write gamma plus 1, and then you write p. So which is equal to right hand side. So it is proved. So this question is very, very important. Okay, so you can copy it, you can practice it at home. Okay, so now this much is for today. So we have done some problems from second order derivative. त आज जति पनि हामीले गर्यौं यो सबै घरमा तिमीले राम्रोसँग रिभिजन गर्नु, होमवर्क दिएको पनि तिमीले गर्नुपर्छ। अनि नेक्स्ट क्लासमा म अझै यो सेकेन्ड अर्डर डेरिभेटिभ माथि अझै प्रब्लमहरु देखाउने छु। सो दिस मच इज फर टुडे।